All right, so we're back in PSPP with our Anova example data set. And I've added 2 more line items from the last video. I've added age and mood. So you can see I have gone ahead and put the values in. 1 is Gen Z, 2 is millennial, 3 is Gen X. I realized I spelled millennial wrong. I thought I fixed that. And on mood, 1 is a low mood and 2 is a high mood. And let's just say that this is some pretend mood inventory that we gave students as they were walking in the class to see what kind of mood they were in as they sat down for their exam. So these are now our variables that we have. So what we're going to do, and you can see they're all filled in. I just went through and randomized them. I actually didn't totally randomize them. I wanted to be able to show you different types of outputs. So, all right. So for a factorial ANOVA, this is what I was getting at the last video that I kind of made a blooper with. So for the one-way ANOVA that we talked about, we do compare means and come down here to one-way ANOVA. However, for a factorial ANOVA, you will notice there is not any option anywhere on the screen that even remotely resembles the idea of factorial ANOVA. And that is because in PSPP, to do this, we need to do a univariate analysis. So we're going to click on univariate analysis. Now remember, let me get all these back. This was from me playing with it. All right, so our dependent variable is our test score. Remember, what is affecting what? Music is affecting test score, age is affecting test score, mood is affecting test score. So our fixed factors that we want to look at, we're only going to look at 2 at the same time. You can look at more than that, but remember, we only have 30 participants in our pretend data set here. So if we were to look at all 3 at the same time, we would have, how does that end up mapping? We would end up having lots and lots of groups, right? Because we would need to know Gen X in class 1 with a low mood, Gen X in class 1 with a high mood, millennial in class 1 with a low mood, millennial in class 1 with a high mood. We would end up with lots and lots and lots of groups, right? Each time we add another factor, we have to multiply that out more. And with only 30 participants, we just don't have the statistical power to do that with this pretend data set. If I made a pretend data set where we had a couple hundred participants, this would be no problem. But so we're only going to do 2, but know that it does have the power, the software has the power, the software has the capability of doing more at a time. So our dependent variable is our test score. Our fixed factors, again, factor, independent variable. Let's look at 2 at a time. Let's start by looking at the class, because remember, this is ultimately what I'm interested in, is does the type of music I'm playing make a difference? The class, and let's go by age. Let's go with the first thing we want to check out is, are younger students more likely to have an effect of the music than older students? So we're going to click OK. You'll notice we don't have any other options here. We don't have the post hoc tests. We don't have the comparisons. We don't have the little statistic button where we can ask for descriptives. This is a very simple window, and it gives us a very simple output, and this becomes significant later on. So we're going to look at class and age and test score. We're going to click OK. What you will find, I don't know why my screen is splitting like this. Pull this over here. Okay. What? That was not helpful. And sometimes, there we go, restore. Sometimes PSPP can get finicky, unfortunately. It's a free software, so we do what we can. Okay, so here's what we're looking at. We see that class has a statistically significant effect. We already knew that. We see that age has a statistically significant effect. We didn't know that yet. But we see that class and age considered together, this line right here is your interaction effect that you're looking at. Class and age considered together does not have a significant effect. So we don't have any interaction effects to look at on this one. We don't need to explore that. Let me show you a couple ways we can double check this, right? So first, let's come back here. First, let's look at our age, right? Because our factorial ANOVA showed us that we did have a significant result by age. But again, we only have this little this. This doesn't tell us anything like the one-way ANOVA did, where we can see which age is doing what. We know there was a significant relationship. We don't know which way that's going. So let's come back over here and do a one-way ANOVA to check that. So we're going to come over here, compare means, one-way ANOVA. My dependent variable is test score. My factor is age. Let's say I want the descriptives, and let's come over here and make sure our Tukey is selected. PSPP is really good at saving your last selection for your current one, but you always want to double check it still. Let's click OK. Let's come back over here to our output. All right, so I knew that age was significant based on my factorial ANOVA that I did. And now I can come down here and I can see that the mean score of Gen Z was 6.5. The mean score of millennials was 5.4. The mean score of millennials was 3.4. I have a verification with my ANOVA that this is a statistically significant difference between these groups. And I can come down here. And again, I want to use this chart to see which of these contrasts are significant. So this one is 0.4. This is not significant. So comparing Gen Z to millennial, there's not a significant difference in the test scores. Comparing Gen Z to Gen X, 0.003. That's statistically significant by a pretty good margin. Say millennial Gen Z, nothing. Millennial Gen X, 0.062. So what I'm seeing here is that comparing these age groups, Generation X is different in their test scores while music is playing in the classroom than Gen Zs and millennials. So that's not really exactly what I was interested in, right? Because my initial study was seeing if there was a difference in the type of music playing. But this does give me an additional piece of information that, okay, having music playing in general, it seems like there is one of these groups who has a lower score than the others. And that's where I could start to make explanations about, maybe it is that millennial and Gen Z are used to just having music playing all the time anyway. That might be more distracting for older students, that's not the way that they learned to study and take tests all throughout middle school, high school, college. So we could do some different things with it. But so that's checking to see what that relationship looks like, since that popped up as significant on our factorial ANOVA. Now, for those of you who are visual learners, let's come over here. We can go to graphs. We can come down here to bar charts. Let me get mood out of here. We don't want this right now. Okay, here's how this is going to work. For our bar chart, what we're interested in comparing is the test scores. So this would normally look like this if number of cases is selected. We want to come down here and say we want another function that our bars are going to represent. And we're going to say we want this to be the mean of our test scores. So our bars are going to be our mean test score values. We want the category across the bottom to be the class that people are in. And we want the bars to be clustered by age. I know that none of this probably makes sense when you see the visual as well. We're going to click OK. Now, and again, this is double checking that we did not have an interaction effect. Okay, what you will see here. So this represents the mean test score. This is the type of music that was playing, and the bars are the different age groups. What you can see is that for each of these groups, Gen Z had the highest score, millennials had the next highest score, fan favorites and ambiance seemed about the same between millennials, just eyeballing the bars. And Gen X had the lowest test scores in each group. So the way you know there was not an interaction effect is that these are all in the same order, right? You don't have one group where Gen X was all the way up here. They go in the same order. And that's how you know there was not an interaction. And we're going to do the same thing when we look at mood. So we can see there wasn't an interaction. We can see this difference that we established in the different types of music. Again, just eyeballing it, we can see that classical was quite a bit higher than the others. And we can see the order of the means. So this is how to do a visual of this. Now, let's look at mood. So now let's say what I want to consider is, did the mood of my participants when they sat down to take the test, did that change the relationship between type of music and test score? So we're going to come back to Analyze. We're going to click Univariate Analysis. And now we're going to tell it we want to see class and mood in relationship to test score. Click OK. All right. Oh, for heaven's sakes. Okay. So what you'll see down here, our class still significant, right? It always has been. Our class is still significant. Mood by itself is not statistically significant. So we can't say, with or without considering the music, whatever mood you were in when you walked into your classroom impacted your test score, right? Because mood by itself is not having a significant effect on test scores. However, class and mood considered together, we have a statistically significant result. We know there is an interaction effect happening here. Now, like I said, we are very limited in terms of how much further we can go with this using this software, but I am going to show you a couple of different things that we can do with this. Let's do the visual first. Come back over here. Remember, we went to graphs, bar chart. We still want our lines to represent the mean test score. That's the main thing we're interested in. We still want to know class. We still want to know what group of music they were in. But now we're going to cluster it by their mood instead of by their age. We're going to click OK. Going to come back over here. And now we see this. So a quick shortcut to knowing, okay, yes, there's an interaction effect, is these are not all in the same order like they were when we were looking at age up here. When we look at the classical music class, we see that this is out of order compared to the other two. In fact, what we see is that students who had a high mood entering the test had a much higher mean test score than students who had a low mood. So that would be where our interaction is lying, is that we can see, okay, something about mood and classical music. Somehow these two variables are playing off of each other. These are creating a difference somehow, okay? So now, one way we can get some actual numbers here, because this is helpful as a visual, this doesn't give me any numbers I can work with. Come back over here. My computer is lagging, my goodness. Okay, we're going to come over here to Analyze. We're going to compare means, and we're going to click on means. What this lets you do is layer your groups. This is going to get you a very similar breakdown to what your textbook gave you. So our dependent, again, is still going to be test score. This is the result we're interested in seeing, is this test score. But we're going to tell it, so you can see down here where it says layers, you're going to tell it what order you want to layer your variables in. So we are going to tell it that we want our first layer to be class. We're going to click forward. We're going to tell it that we want our second layer to be mood. Okay. Again, you'll notice we don't really have any other options here. We don't have anything else that we don't have anything else to select. We don't have anything else to tell it. Let's click OK. Let's come back over here to our output. All right. Now, what you will see is a breakdown showing you the mean score in the classical group for low and high mood, and the favorites for low and high, and the ambient for low and high. So I can see, compared to my bar chart up here, students in a low mood who listen to classical music had a mean score of 5.25. Students with a high mood who listen to classical music had a mean score of 8.17. Now you'll notice over here, this really is not giving us anything that is statistically significant. But what we can do, just as a common sense thing, if we remember our means from before, I believe that the total mean of the group was something like 5.1. But we can see, okay, so what's happening here is that the low mean of the classical group is not that different from our grand mean that we had talked about way before. So maybe if you're in a bad mood, listening to classical music really isn't doing that much. But if you're in a good mood and you sit down to take this test, then you get that effect that classical music is really helping to improve your test score. And you can break this down with all of these. So the fan favorites, their mean was 4. Their mean test score was 4. Low was 4.6. High was 3.4. So this one was actually working opposite. And again, made up example. You can do with whatever you want with it. I was trying to put numbers in a way where I would have something significant to show you. But on this, we would need to say, okay, something weird is happening here, because students who were in a bad mood and listened to these types of music had a higher average test score than students who were in a good mood. So again, made up example, but that's where we would need to look at these and say, okay, I need to figure out what these relationships are, what's going on here. But the most important thing is, again, remembering when we did our Anova before, we saw that it was the classical music group that was showing a statistically significant difference than the other groups. When we did our univariate analysis, we saw that music group was still significant, class was still significant, and we saw there was an interaction effect between mood and music. And so now looking on here, we know our area of interest based on this chart, based on what we already knew about our data, was probably going to be this classical music group. And now is where we see, okay, there is this interesting relationship, in that the impact here for students who entered into the room in a good mood with a high mood seems to be very different than the other students in this group. And that is the basics of how you do a factorial ANOVA and how you can interpret the results. Again, note there's no significant different box over here, so we cannot break this down to say which ones are statistically significantly different. That would take different software and different statistical procedure. But it can give us some numbers to start looking at. And for the purposes of this class, this is enough for understanding the basics of a factorial ANOVA.